Okay. All right, let's take a look up here. Now, so this chapter is about matter, and we've talked about matter is anything that has mass and takes up space, right? We even talked a little bit about what inertia was. Inertia and mass are just like that. No matter where you go, if you have more mass, you have more inertia. But then chemists figured out, or actually scientists, they said, how can we classify matter? And they said, well, here's one way to do it. And I'm going to review this. This is our review, okay? One way to do it is, you know, there are only some things that we know of that you can only make them one way. Okay, I'm going to have you guys stop, okay? Sean, you guys stop. Stop. Okay. There's a group of things that there's only one way to make them. And somebody decided to call them substances. And the book sometimes says pure substances. Now, what kind of things can only be made one way? And they said, if you're a substance, you're either a what? An element. And how do you know if something's an element? It's on the periodic table. And that also means, it also means they're only made of one type of atom. Like even a whole piece of, I have a piece of copper here. Here, look at that. Here's a piece of copper. And that might be trillions and trillions and trillions of atoms. But every one of those atoms is copper atom. So elements are only made of one kind of atom. There was another kind of substance, pure substance. There's only one way to make it. And that's when atoms chemically combine with other atoms to form a what?
Chemical bond.
Chemical bonds makes a compound, right? And there's only one way to make water. 2 H's and 1 O chemically bonded together. There's only one way to make carbon dioxide. 1 C and 2 O's. Now, how do you know if something is a compound? I have to tell you and give you the chemical formula. We have a chapter later where you'll know how to write your own formulas. Right now, I have to give them to you. If I say that something has a chemical formula in C6H12O6, then you know it's a compound, don't you? Yep. And if it's a compound, it's also a pure substance, and it's also a form of matter. Now, in your brain, one part of the test is something like this with a flow chart. Is this matter? Is this a pure substance? Is this a compound? Is this an element? And your brain has to work like that. What about things that go on this side? What makes a mixture not a pure substance? I know it's Monday morning, but why is a mixture not considered a pure substance? Hey, can you close that door for me, Thomas, while you're up? Yes. Mixtures can be made many ways. You get that? How many ways can you make a salad? How many ways can you make salt water? Many ways. Okay? Now, what kind of things are mixtures? Another thing about mixtures is you can always separate the things in the mixtures, and you don't have to use a chemical reaction. You want to separate things in water? You want to separate H from O in water? You better have a chemical reaction. What was the drawing? One of the homework you're doing this Friday, are the drawings, aren't they? One of the drawings is where they have electricity running through water. And what's collected at the top there?
Water.
What is it?
Electric juice.
2 gases. What are they? Hydrogen and oxygen. And they have a fancy name for that, electrolysis. In the 9th grade, you might have learned about the word lysis. Lysis means to split. Okay? Maybe you had that word lysis, to lyse something. And electrolysis means use electricity to split. And it's a great name. But what kind of is that a chemical change or a physical change? When you split water into hydrogen and oxygen, is it a chemical or physical change?
Physical.
I know you can flip a coin and guess. But didn't we have a compound and split a compound up? What kind of change do you have to split a compound up? Chemical. That's a real chemical reaction. But what about mixture? Do I need a chemical reaction to take the tomatoes and the carrots and separate them? No. Do I need a chemical reaction to get salt and water away from each other in salt water? No. I'll let it sit out. The water will evaporate and the salt will be left behind. I didn't need a chemical reaction. That's another thing about mixtures. They can always be separated with ordinary physical means, physical changes. Now, one more thing, and I'll stop reviewing, is there's another thing about mixtures. You can say, what if you look at them? If you look at them and everything looks like it's made of one material, but it's not, even under a microscope, you know what Kool-Aid looks like? It looks like one material. And that's called homogeneous. So this mixture is a very special kind of mixture because it's mixed so evenly that you can't even tell it's made of more than one thing. And what's the special name for a homogeneous mixture?
Solution.
A solution. Now, we can have solids can be dissolved in liquids, can't they? Salt water, that's a solution. Could you have liquids dissolved in liquids?
Yes.
Yeah, we talked about that. Can you have gases dissolved in liquids?
Yes.
Carbonated drinks. And can you have solids dissolved in solids? Yeah, but the trick is you have to melt them first, don't you? And what do you call that? One of the most famous alloys is steel. Do anybody know what steel is made of? See, steel can't be a pure substance because it's not on the periodic table and there's no formula for it. So it must be a mixture. But if I look at a piece of steel, it looks like a one material.
Oh.
And so it's called a solution. And a special name for that kind of solution is called an alloy. Now, the most famous alloy you'll ever run across is probably steel. And it's almost always, the main ingredient is iron. You have steels that are 99% iron, 90% iron. You can alloy them with chromium. Chromium and iron make stainless steel. Almost all of you eat dinner with forks and spoons that are stainless steel. And that's an alloy. Another one you've heard of is, did I do the gold thing the other day? Okay. 24 karat gold is an element. That's an element. But 18 karat gold is not. 18 karat gold is an alloy, a solution, isn't it? Okay, you all right there? So let me show you what the test question would look like if I made the chart like that, okay? So here's a chart that I made. It's the same chart you're seeing here, except I left out all the writing. Okay, got it? I would put a number on the box, 1, 2, 3, 4, 5, 6, 7. And then I would say, ready? Let's do 18 karat gold. And you say, is it a 1? Is it matter? You say, yeah. Everything, yeah. 1. Now, is it a 2 or a 3?
2.
Wait, we're guessing. Let's look at it before you say anything. 18 karat gold. If it is pure substance, it better be on the periodic table, or it better have a formula. And 18 karat gold doesn't. So 18 karat gold is a mixture. So you say 1, 3, then what? Look up here. 1, 3, and then what?
4.
When you look at it, does it look like one material? Is it homogeneous? Or can you obviously tell it has more than one thing in it? You can't tell. I have 18 karat gold right there on my ring.
Wow.
24 karat gold is too soft. This ring would be an oval every day.
It'll melt.
Well, they all melt, but 24 karat gold would be so soft I could probably take my hand and squeeze it into an oval. So 18 karat gold is harder, and they make necklaces out of it or rings and things like that. And so it is this. So it'd be a 1, 3, 6. See that? All right, let's do dirt. What do you think dirt is?
Compound. I mean.
Oh, if it is, I would have to tell you the formula. And there is no formula for dirt.
I meant mixture.
It is a mixture. What, is it a 1?
No.
It's not made of matter.
10.
Wait, it's not made of matter?
No.
It's not. Yes, it is. What? You don't know too many things that are not made of matter. Something like heat, light, sound. But take a look. So dirt is a 1. Is it a 2 or a 3?
2.
1, 3. Is it homogeneous or heterogeneous? 6 or 7?
6.
Okay, I'm not going to make you go out and get some dirt, but every time I've looked at dirt, does it look like it's exactly the same thing throughout? No. And so it's a 1, 3, 7. Let's do another one. All right, water, H2O. What do you think? What do you think? 1 or not? Is water made of matter? Wait, What do you know that's not made of matter?
Heat.
Huh?
Heat.
Well, this is not heat. It's not light. This is matter, isn't it? Okay, water is made of matter, isn't it?
Yes.
Now, what is it, a 2 or a 3? A 2. How do you know it's a pure substance, though? Because what? It's a 1, 2, what? What else is it? Is it this?
4, 5.
Is it a 4?
No.
You know how I know it's not a 4? You know I know there's no such thing as an atom of water? You know how I know? It's right there. Water's not up there. There's no such thing as an atom of water. There's no such an atom of steel, is there?
No.
If you're not up there, there's no such thing as an atom of you. So I do know it's matter. It is a pure substance because it had, and it's a compound, isn't it? 1, 2, 5, isn't it?
Yes.
Because it has a formula. How about steel? Hayden, what do you think? You do it, Hayden. Do steel. Is it a 1 or not? Yeah, it's a matter. Is it 2 or 3?
It's 2.
If it's 2, you better tell me it's either on the periodic table.
It's 3.
Huh?
It's 3.
It's 3. Okay, 1, 3.
3.
Wrong.
When you look at a piece of steel, does it look like it's made of many things? Here's a piece of steel. All right, so it's 1, 2, 1, 3 what? 1, 3, 6. You're right. How about air? Aiden, you do that. Do air. Is it made of matter? It is. You don't want to say it if it is. I'm getting ready to do next week. I'm going to go down to the third grade. They're going to come here. I'm going to do like a half an hour science program for them. And you know what? I'm going to prove them that air has weight, it has mass. And I'm going to take a balloon and weigh it, take the air out and weigh it again. It weighs less. You get that? Air is matter. All right, so it's a 1. What else is it? 2. Okay, if it's 2, you better be able to show me on the periodic table where it's at, or you better tell me the formula for air. Do you know the formula for air? Is it a compound? I don't. Is it on the periodic table?
Oxygen.
I didn't say oxygen. Do you know only 20% of air is oxygen?
Yeah, it's like 70% nitrogen.
So it's not one of these. So you better not go here. You better not go here. So 1 what?
3.
1 through 8. Now what?
6.
6. Yeah, because it looks the same throughout, doesn't it? There you go. Now, one other thing that I might do, and I'm not sure why you're having a little trouble with this, but the good news, we don't have the test till Friday. You got plenty of time. But what if I do this? What if I make a charts different? See, some of you think, well, you'll make the chart exactly like on the handout sheet, and then I'll be able to. No, maybe I won't. Why don't I make a chart like this? Instead of saying, are you a pure substance or a mixture? Are there many ways of making you or only one way? What if I ask this question? Hey, let me look at you. Look at that thing right there. Look at that. I'm going to look at you. Are you a 1? Are you made of matter? Yeah. And when I look at you, do you look homogeneous or heterogeneous? I can clearly tell there's more than one thing in there, can't you? So you're heterogeneous. But if you're heterogeneous, then it means you are what? A mixture. But what if I did something like the tea that's in here? I'm not going to dump that out. The tea that's in there, what if I looked at it? What would it look like?
Brown water.
It would look like one material. But wait a minute, if it's homogeneous, it could be either this or that. Because what is a homogeneous mixture? A solution, that's what this is. And so, is it a solution? Is my tea a solution, which means it's also a mixture, or is it a pure substance? And again, don't make this hard. If it's a pure substance, it's either what? An element on the periodic table, or it has a chemical formula. There is no chemical formula for tea. Got it? So what is it? So it's a matter, it's homogeneous, it's a solution, which is also a mixture, isn't it? Now, the only reason I want to show you that is that if you really know these words, there's about, 10 or 12 words in this chapter. If you know how to compare and contrast them, you'll have no trouble with that part of the test. Okay? If you keep telling me that things that are made of matter are not made of matter, that's a problem. All right? So what I'm going to do is I'm going to leave this behind. I may revisit it again, but I want to do, I want to get into some other words, and I want to use some demonstrations. Yes? I'm going to say no, okay? Oh, wait. Let's wait. Okay, now what I'm going to do is I'm going to go over here, and I don't know. I think I can do this. I want you to, if you're sitting over there, I want you to come over here and have a better seat, okay? So come on over here. Here's what I'm going to have to do. This might not work. Let's see if it works or not. All right, it might work. All right. You guys, you need to sit close enough so you can see, all right? What I'm going to do here is one part of the test, which can be really easy or can be really hard, is things about changes. Remember your notes? Remember we had the word physical change and chemical change? Remember that? Let me see some here. I got some stuff here. Get rid of this here. We got one more thing. We're gonna get it. There we go. All right, there we go. I have some sand here. Let me go ahead and.
Is that from the beach?
Yeah, well, no, it's actually from. You can buy a bag of sand at Lowe's.
So they get that from the beach?
Well, maybe. Sand is actually little bits of mountains, and so if you wait long enough, a mountain will give you a bunch of sand.
There's mountains at the beach.
Huh?
There's mountains at the beach.
No, but the sand could have come from hundreds of miles away. As the rain hits the water and hits the rocks and makes them smaller as they tumble along the stream. Anyway, so sand comes from that. So if you were to block off a river, if you block off a river in a certain place, the people at the beach would say, "What happened to the beaches? We don't have very much sand anymore," because the source of sand was coming from the river, and you blocked it off. And so some people will they'll go to court and say, "What about my resort town?" You know. Anyway, I have some sand here, and if you look at it, it's made of matter. Is it heterogeneous or homogeneous?
Hetero.
It is. I can tell there's more than one thing in there, and so sand is like that. And so it is a mixture, right? Heterogeneous mixture. Let's try something else. Let's see my salt. Oh, wait, there it is. I had to move some stuff around the other day. Thank you. There's salt. This is table salt called NaCl. Is it homogeneous or heterogeneous?
Homo.
It is. And it does look the same throughout. And it actually has a chemical formula. So not only is it homogeneous, it's also a compound, isn't it? And that means it's also help me out.
Mixture.
No. It's a pure substance and made of matter. So I'm going to put some of that in here. And now what I have here is, if I go like this,
Salty sands.
what would you call this?
Salty sands.
Yeah, but how would you classify it?
A mixture.
I mean, if it was a mixture, then I can definitely see the salt in there. It's still a mixture, isn't it?
Yeah.
Heterogeneous or homogeneous? Heterogeneous, okay. And I think I'll mix something else in here. I'll put some pieces of iron, yeah. These are called iron filings, and a piece of iron. Oh, too much there.
Whoa.
Now what is this? How would you classify this?
A mixture.
What kind of mixture?
Dirty
Heterogeneous.
rocks.
Well, remember, all mixtures can be separated. Now my goal is I need to separate these things. And so how can I separate? I'm going to add something else. Let me add something else.
Use a magnet.
That's some water. Now what is it?
Water.
Solution.
No, it's a mixture.
And I can tell there's different things in here, right? What kind of mixture?
Oh,
It's still a heterogeneous mixture, but now I need to separate them, and you're right, I'm going to go get one of these because every one of these things in here has a set of chemical properties, meaning how does it act in a chemical reaction, and has a set of physical properties, which might be color or mass or like this, magnetic. How can I separate these four items? Well, I could do this first, because only one of these things is actually magnetic. So I separated the iron from the sand, salt, and water. Now I have sand, salt, and water left. Now I want to separate them. How do I do that?
Not just boil it. And then
What now?
Boil the water, not the salt.
Okay, we could do that. We could do that first. I'm going to do something else a little bit ahead of time.
use the sand.
So what I'm going to do here, I got a piece of filter paper. All right, and what I'm going to do is pour this through there.
How are you going to separate the salt and
Okay,
sand?
okay. Now, what is it that stayed up here though? I had water, salt, and sand.
Water. Sand. Salt water.
What's interesting about salt is soluble in water. What does that mean?
Dissolves.
It dissolves and makes a solution. And when you have a solution, all of that goes through the filter. So we have salt water here. This is salt water, and the sand will be left behind. Is that right? Okay, then the next thing is, how do I get the salt away from the water?
Boil.
Okay. One of the
What if there's
drawings,
still salt and sand?
one of the drawings you have to do for homework is called a distillation. Distillation. And what happened is I had a student in my other class, C class, and they're very interested in that. They do the drawing, and I showed them an apparatus that you could use, but I didn't ask the school to buy a bunch of those, $150 a piece, and I didn't think it was worth to do a lab with it. But we had one of those, and he said, "I just like to see that thing work." So he stayed after school on Friday, it's for extra credit, and what we did is, I'll show you, I'll come over here. And here, move it a little bit this way, Thomas. If you'll take a look, here's what he built. So what we have is, I put a bunch of salt water in here. Wait, if you sit there, that's called eclipsing. You sit over here. There's still, now you can't see. Yeah. So you guys need to move that way. And you need to move this way. Way over here.
Oh, wow.
All right. I had a bunch of salt water here, and I used a burner. And I'm going to heat it. And I don't know if you know this or not, but if you heat salt water, the steam is not salty. Only the water will turn into steam. And now, if I had steam, the thermometer simply told me what the temperature was in here. And so the steam came up here and came out this little arm here and went down. And this is a neat little thing here. This is called a condensation apparatus. Now what it is, it's a tube inside of another tube. So there's a tube going down the middle and a tube on the outside. So let me show you, let me turn the water on, show you what happens here. All right, so the water goes from down here. We had to figure out how to do that. We had to get the water through this tube. It goes in here and goes on the outside like that. And it forms cold water. Is going to be in the outside all the time. And it comes down to the drain. See that? Now, when you heat this up, the steam is coming out. And when it hits this pocket down here, the cold water will change it from a gas back into a liquid. And what will happen is, down here in this bottle is distilled water. It's pure water. And what was left behind? What was left behind here?
Salt.
Salt. And so, in order to separate things in a solution, I might have to use a thing like a distillation apparatus. Now, again, I don't want to get too much into this. The other day, I talked about alcohol, so I'll do one more alcohol talk, and then we'll stop talking about alcohol. But there are people who are called moonshiners. They may have dropped out of school. They may be really smart. Or they probably looked at their grandpa, and the grandpa says, "You want to know how to make moonshine?" And here's what they did. They had this great big copper pot. Copper absorbs heat really well, so it's good for heating things. Yeah? And they would put things in it like corn mash. And there's also little microorganisms like bacteria or yeast. This is yeast over here for another experiment, for another one. And so what you do is you let it ferment. In the 9th grade, you heard about this thing called alcoholic fermentation. Maybe you did, maybe you didn't. Fermentation. It's where microorganisms break down food and they give off carbon dioxide and stuff like that. And some microorganisms, when they break down food, they produce alcohol. So now these moonshiners have this mash, this kind of smelly stuff, and the microorganisms are making alcohol. So then what happens? I need to get the alcohol away from the water that's in there, away from all the other stuff, and so they heat it. And they heat it to a certain temperature, the alcohol turns to steam, to a vapor, and then do you ever see the pictures of a still? It has a copper pipe, goes like this, like a coil, copper wire, copper tubing.
Yeah.
That's because as the hot alcohol steam comes out, it cools and cools and cools, and then it turns into a liquid, and you have pure alcohol coming out the other side of the still. They call it a still, by the way, instead of distillation. All right, what do you think? Anyway,
Cool.
I wanted to show you too because I've never actually set that up before, and so he was willing to come, and we worked it out. We had to learn how to. We took this off, and
Can you turn the water on again?
I did.
Can you turn it? I want to see
Yeah, but
it.
I don't want to. And then see this. All right. What time do you have today?
30. It's time to go.
All right. Thank you very much. Tomorrow we will finish chapter 3,